Welcome to readmeproject.com. Project title: An online algorithm for data collection by multiple things in wireless sensor networks. Now we are going to see the abstract of our project. With the explosive development of the microelectronics and wireless communication in recent decades, wireless sensor networks have been one of the most active fields in research community. Most of the wireless sensor networks consist of static sensors, which can be deployed in a wide environment for monitoring applications. Data collection by multiple things is a fundamental problem in wireless sensor networks. Existing works focused on designing the optimal offline methods, provided that the number and the position of sensors and sinks are predetermined. This may not be practical as those sensors are cheap and also sinks are quite expensive in reality. A more practical scenario in that sinks are deployed step by step during the network operation due to the budget constraint, and we do not know the number, positions and capacities of sinks in prior. In this project, we investigate the problem of data collection by multiple sinks and design a suboptimal online algorithm via primal dual approach, requiring very little priori algorithm. We theoretically derive the computative ratio of the online algorithm and further improve it by finding the optimal sync location with an approximation ratio. We also analyze the computational complexity of the improved approach. This framework evaluates the network loss probability performance, which only requires local information for collecting data. Extensive simulations are conducted to demonstrate the performance of the proposed online algorithm and performance complexity trade-off. Let's see the flow of our project. First, the network formation is done. That is, the network is formed within the transmission area. In that network, the sensor nodes and the base stations are created. That is, the multiple sinks are created in the network. After that, the sensor nodes generates data. If the node have data means it is done by the online algorithm. With the help of the online algorithm, the node position, its data are all calculated. So if the node have the data means it gets the details and then it collects data from the sensors. If the nodes have no data means the sinks are transmitted in the locations to gather the data from the nodes which have data. Finally, the performance analysis is processed, in which the existing work is compared with the proposed system in terms of its performance matrices. Now we are going to see the output demo. First, open the terminal window, then go to the directory where we have the code, then type ns space filename.tcl. So this is the main command to run our code in ns for network symmetry and space the filename.tcl. If we give enter means the nodes are created and the code is running now. Since it is a sensor network, we have to update its position and energy to find out the nodes that are in which positions in the network. So it represents the online algorithm. This is the network animator window. Here only we see the output. These are all the nodes that is created in the transmission area. To run the simulation, click on the play button. So now the simulation is running. These are all the mobile things in the network. This is the simulation time that is running on here. We can speed up the simulation process. Since it is a mobile thing, the nodes are moved in the transmission area to collect data from the sensor nodes. After some time, the nodes generates data means it forwards its data to the nearby sinks. So here we created the multiple sync concept. The online algorithm performs here, that is the nodes are generates data. Its details are updated to the nearby base stations, and the nearby base station will collect data from these sensor nodes. Like that. Now another node is communicated with this base station. Like that, all the nodes in the network generates data and forwards it to the nearby sink. So it finds out the shortest path and it forwards data according to the routing procedures. To see its graph, back to the terminal window, then type GNU plot graph1.plot. So this is the delay graph. Here the number of sinks are varied 1, 2, 3 like that, and the delay is calculated. How many delays occurred for the packet collection. So existing have higher delay, that is offline mechanism have high delay, but our proposed online algorithm only have less delay. This online algorithm or represents as the nodes each and every informations are updated here, and also the positions, energy, and the node speed, hop distance are all updated. So these are all updated in the neighbor.doc text file. So here we can able to say that at which time which node is communicates in the route, that next hop neighbor is what. So all the informations are updated only on the communication process. That's all. The demo is completed now. Thank you for watching this video.